Say hi,
FPV.
I'm Scott. I'm going to talk a little bit about why I kind of got into drones, sort of what I learned from it, and I'm going to show you a few practical examples. So let's just sort of flip over here. I have a few slides, just kind of keep me on track. Let's get away from Moon Knight stuff. Oh, all right, you see that?
Yep, you're all set.
Cool. Yeah. So, hi, I'm Scott. Anyone that wants to grab this deck and anything I talk about, just like the link is tinyurl.com/SAC Interactive FPV. And that'll get you this deck. And there's links at the end with like all the stuff I'm talking about. So, this will be really good for the replays. Anyway, hi. My name's Scott. I'm a polymath with a music degree who's built a kind of weird haphazard career leaning into technology for fun and profit. I've done a lot of things for my day job over the years, but mostly I've it's been to fuel the stuff that I like to do on the side, which is mostly digital image, video, music and audio production, web and UX design, and well, less now that I'm much more fragile, but extreme sports for quite a while. Why did I get into flying? So to rewind, one of the first sort of extreme sports I got into was skydiving, and I was a jump master for about 6, 7 years when I lived down in Santa Barbara in my first software job. I absolutely loved it. Really, I wanted to be a pilot since I was a kid, but that was about the closest I could get to it. I didn't want to go through the full pilot's program and actually get a straight up license. So I figured that would be a way to get into the sky, and I really loved it. Problem was I beat myself up pretty heavily with it. And then when I finally met my soon-to-be wife, I decided, yeah, I'm going to put the life-threatening hobbies away for a little while, do things a little bit more terrestrial. So I didn't really think about flying for a long time, and it wasn't until much, much, much later, after I had just gone through a really, really bad accident, which kind of flatlined me, and a series of medical procedures to kind of get me back to health for the 4 or 5 years after it. And it was just a big change in my life. I realized that like my physical sports life really needed to change, and there was part of me that really didn't want to let go of it. So around that time, a friend of mine, Alan Musselman, who was a friend at Adobe, we were both product managers there together, was coming through town, and he said, "Hey, like I brought my drones. You want to try it?" I was, wow, I'd never really thought of that. So we went to the park, and I thought he was just going to give me one of those little, toy helicopters that you kind of pop up and, but it was the full goggles, the whole 9 yards. And in 5 minutes, I was absolutely hooked. It was everything I thought it would be. So the reason I got into it was mostly my body was broken, and I was going through a lot of stuff at the time, like physical rebuilds. My marriage was in shambles. I kind of needed something to sort of focus around. And I'm sort of the person where if I'm taking on a hobby, it needs to be something that I can really learn real world skills from. So drones was it. I decided this is it. I'm going to dive in. I want to learn everything I can about these things. So the first thing I asked my friend is like, which one should I get? Like there's so many things. And he kind of laughed at me, and he walked me through the three big categories, but said like, I'm going to go through the paces here and explain this to you, but I know how this is going to end up. So here's what you want. And I told him I really just wanted to revisit and capture the sights and experiences I had when I was skydiving, but I didn't really have the tech to capture when I had the chance. And I wanted something that was like felt fun. So we walked through the options. He's like, you can get the commercial camera drones. I think we're all familiar with these, like the Mavic series. Skydio makes a really great one. These are the commercial drones. They're really stable. They're safe and fun, and they're consumer friendly. I mean, the pros are you really have to try to crash these types of drones. Once they're up, they kind of fly themselves. They have GPS precision, so you can't really lose them. They always come home, and their cameras are fantastic. They're made to be super stable and with amazing optics. Now, the flip side is, if you've seen some of the most recent drone footage, it's like very, shall we say, dynamic. These are amazingly conservative. You can't really do anything fun with them. There's no really good FPV options, or at least immersively. And aerobatics are next to impossible because you can barely kind of tip it on its side, let alone flip it over and do fun like, Immelman turns and stuff. So I immediately thought, like, for creatives, that's cool, but like I want something that feels a little more fun. So we looked at the consumer FPV drones, and the DJI FPV is a recently, sort of a much more recent development here, where it's a kind of a turnkey solution for people that want to fly FPV. But back in the day, tiny whoops were the way you did that. And it's basically these little teeny quadcopters, just about this size. And they take a small battery around the size of a AAA. They fly for about 5 minutes, but you can do it directly in real FPV goggles, and they're safe in the house, everything. And I'm like, okay, now we're getting, this is sounding a little bit more fun. It's immersive. Technically it can do flips and stuff, although they're really small and don't do them well. The pros for these consumer FPV drones are that obviously it's FPV. You're seeing out of the craft. There's a lot more options for flight control, stabilization techniques, different ways that you can program the flight controller to make it an easier fly. And it also have acro mode, where you can turn off all the stabilization and just go absolutely full ham. So this was starting to sound like my first option. I think I needed to go for this one. I didn't want to really build one, but like this felt like it had what I needed. The real cons here are that they're a little harder to fly. They're sort of sluggish. They always feel like you're kind of chugging uphill with them. You can do acrobatics, but since they're so light, like a little bit of wind will just kind of blow them like a leaf too. So you can't really hold a line with them. And I got my first rig as a consumer FPV drone, and it lasted for about 2 weeks. I wanted more. And that's when I went for Alan's third option. If you really want performance, you've just got to build it. The good news about custom FPV drones is sky's the limit. There's a bunch of different frames and types that you can start with, but they're all kind of a blueprint that you build upon and customize to your own needs. I mean, the pros here are that like the really best FPV is with these because you can customize the components. Extreme acrobatic characteristics. I mean, you can flip them, you can twist them, you can bounce them off walls. You can do all kinds of crazy stuff with these drones. You can get racing speeds. You can overpower them as you see fit. I've had some just crazy, like 150 mile an hour drones we put together just to see how fast we can get on a radar gun. And the coolest thing about this is it's all built on what's essentially an open flight platform for makers. The flight control software is open source and it's developed very actively, so you can contribute to it. It's always moving forward, and it's just seemed like a really robust community. So all of these things for me as a former developer sounded like, yep, now this is definitely my jam. So no surprise, I went full custom with a lot of help from YouTube. I will say that anyone who's really interested in building custom drones, YouTube is going to be your best friend because all of the best makers are there. All of the best content's free and open source. And although can be a little bit of a macho jarhead community at times, a lot of dudes with like extreme sports egos, it's actually become a much more diverse community too in recent years, which is awesome. I think with DJI entering the market, just a lot more people are starting to realize what you can do with FPV. At this point in time, most people have seen like the bowling alley video with the guy flying through all the stuff and all those crazy sort of gap tricks that are coming out with the drone videos now. That's just from the community getting bigger and much more diverse. And it's really been awesome to see. So my goals here when I dove in was I wanted to build high quality drones that had extreme performance, but were also capable of like capturing really good video and data so I could build for profit if I wanted to. And it just had to feel fun. As a musician, there's like something I always had problems with samplers and like electronic drums. Electronic instruments in general is the latency between when you do something and when you hear it, when you feel the response. And if it's off, it just doesn't feel right. You can't get the groove. And especially like the type of flying I wanted to do it just needed to feel almost like locked on rails. So this was the part that I was most concerned about. Like, am I going to be able to get anything that ever feels that way? It needed to feel as immediate and immersive to me as when I was jumping out of planes. And I just got that rush. I'm in the air. I wanted to forget I was wearing goggles. So, yep, let's tell my story with pictures a little bit more now for my learning curve. Here's one. I actually busted up my elbow uh, flying drones too. Don't ask. Like, it can get pretty crazy. So, the cockpit. Here are the stuff that you need. So, as you're diving in, no matter which of those latter two options, yeah, anything other than consumer camera drones that are all sort of all-in-one systems, you're going to need a really good transmitter, which is the controls, the sticks, and you're going to need a really good set of goggles. My two are these here. I'll kind of hop off Zoom video for a second. Let's just dump screen share. So this is a Taranis. It's the X9D Plus. This has been around for, I want to say 10, 12 years now, but it's one of the best. It's got pretty much everything you would need, and it's built on an open source platform, so you can hack it to anything you want. The other reason I like it is it has a JR port in the back that lets me plug in different protocols. So I don't have to have different controllers for different sets of craft. I have different modules. Most of them go through what's called Crossfire protocol right now, but depending on what wings and quads I want to add, I can just sort of swap that out, and I don't have to carry a bunch of extra gear. For my goggles, these days you can either go analog or digital. DJI has kind of cornered the market on digital. And it's digital, as you would guess. There's no analog to it. It's transmitted over the air, but it's a purely digital signal. Analog is the other option. These are the goggles I mostly use. The Fat Shark HDO2s. So basically high definition. It's almost wraps, but it has just amazing response time. And the reason I liked using analog over digital is exactly that, the latency factor again, not just in controls, but with the video link. You do see latency as things get a little further out, a little bit more latency is introduced. With analog, there is no latency. It is a signal. You will see a bit more as you go further out, but it generally tends to be almost instantaneous. Let's see. So that's my cockpit and what I like to use. So jump back over to the slides again real quick. So onboard tech. I'm going to use this little picture here as my example for a second. What goes into a quad? Well, you pretty much know there's a camera to see out of, and there's propellers and engines, but everything that kind of goes between that is what's really important. In the center is the flight controller. That is CPU, a gyro, a barometer, and then a whole lot of circuitry to basically balance four, some cases six, in some cases just one or two engines, and make them all work in tandem together. So it basically takes the input from your sticks and translates that into a four-way power distribution. The power comes out through these four things that you can see here on the kind of zip tied to the arms of this are electronic speed controllers, ESCs. What they do is they take basically a modulation signal with two wires and then power with another two wires, and they electronically control the amount of voltage that you're sending through them. So that's how you control the voltage and essentially the speed that goes through the end of it to the engine, which sits down at the end there. And that's the powertrain in a nutshell. There's two other components two other systems that are really important here. See, like central all the way out to the wings, that's your powertrain. I also used, although these ESCs are on the stems, I also use a four-way ESC in a lot of builds that takes it off here, and it's another board that sits underneath the flight controller, so it keeps everything nice and clean, especially if I'm going to be doing a lot of bad weather or like really crummy terrain flying. I sort of want to get all my electronics inside the main chassis as much as possible. But if I'm doing long range, which is what this build is for, having the ESCs out on the wings helps because the air cools them down and it helps keep everything a lot cooler for long flights. And then you get better power distribution, which is like a longer flight time. So the other systems that need to come into play are your control link. That is what takes the on-air signal from your controller and applies it to the flight controller. This sits back here in my builds. It sits right back here in a little custom 3D printed shelf. And right underneath it is the video transmitter, which essentially takes the video from the camera, passes it through the flight controller so that it can get on-screen display for my headset. I can see things like speed, altitude, direction, like how much battery and juice I've got left, all that stuff in my goggles. And then it goes out to the transmitter and it's sent to me in my goggles. So it's like all my goggles are is really just a kind of a dumb TV that's sitting on top of my eyes to tell me what's happening on the flight controller and through the camera at all times. There's some other tech you can add into these too. GPS is common. Having a secondary HD control camera that you control with what they call UARTs or some of the various switches can be programmed on your transmitter to be able to control those as well. LED lightings, especially for racing, are very popular, especially turning them on or flipping different colors based on, like if you need to come into the pits, sometimes you need to kind of switch colors while you're in air. But these are the general systems. I will say that the thing I did not expect was how much soldering and circuit design I was going to have to learn to be able to put these things together. Just take a quick look at how big all these things are in practice. I actually have, where is it? There's one of these. Let's take a look at a couple of them. This is what I call number one. This is my main one. It's built on an Armaton Marmot frame, which is a carbon fiber frame. This is actually a really cool woven carbon fiber, so it's about twice as burly as your usual weave. On top of it, I have a custom GoPro mount that I've printed. Just kind of pull it apart, slide it in there, and clamp it on there. I'm going to hold a GoPro Hero to get that really sweet HD footage. Underneath it here, this is the FPV camera. Take off the lid real quick. That's the camera that I'm seeing out of. So that way I can have this really concentrating on getting high quality footage. This one's concentrating on getting me as fast a real-time link to what's happening in the air as possible. Within it, let's see, let's jump in. This is back here. This is the antenna for my control link. This is my video transmitter antenna. They're in a cross pattern here too, so that they don't interfere with each other. And then everything else, as you can see, this one doesn't have the ESCs on the wings. These are just kind of really clear or really, really thick shrink wrap to protect the wiring. But you can see underneath the flight controller board, there's a second board down there that actually is all four of the ESCs in one. Now, this is the common platform that I build off of. This is my favorite frame. So if I'm going and doing commercial shoots, I'll usually carry, this is my main one that gets all the cool flippy floppy, like flying through little teeny holes stuff. If I want stuff that's more like environmental, this is my long range one. This is also open, so you can see inside it a little bit more. This is exactly the same one that you were looking at in that picture earlier. It's just has a different camera mount on it now. But to show you the thing, this is where the transmitter or the receiver for the control link sits, and then right on top of it is the video transmitter in this bed. And then up here is the GPS unit, which you generally want to keep away from all the other electronics and in free air as much as possible so that you never lose a signal. This is a really specialized one. I usually don't put GPS on my drones, but since this one, I was doing a lot of mountain flying, like up mountain ravines and doing those ravine dives. And when you're doing that, you really want to know, like when it goes down, I want to be able to go rewind in my goggles and get the coordinates. Saved quite a few of these things for me. And then there's one more around here. So, oh yeah, here. Then this is the stunt one. I actually have a camera mount on the bottom here, and what that usually does is has a long stick that comes out the back and holds a 360 camera around here. So you get basically it's in the camera. It looks like this while it's flying. So it's it's just different ways to get footage with those ones. But that's the basic onboard tech and what kind of goes all into it. Just jumping back over to the deck. Am I already out of it again? Hold on. Sorry. Okay, let me share my screen one more time. Here we go. Okay, so HD footage. For that, the cool thing about the builds is the camera that you're the most concerned about is the one that you have to worry about the least. I use GoPros. Actually, instead of using the current, I think they're at GoPro 10 or 11 now, I sort of stopped around 7. That's when they introduced Hypersmooth, which is really, really good stabilization. And at that point, until they go to like, 8K, I don't think there's anything more I need out of the camera. At that point, it's mostly just getting small, making it smaller and more efficient. Now, the trick is that since everything's custom designed, this is the one area that you do have to sort of design around and print and build for yourself. So these are just a few different camera mounts that I've used over the years. Everything from sort of funny ones. This one looks like a skull. This one's a little bit more protection to the lens, so in case I'm hitting things head on. This one down here is super light, so if I really need power to weight ratio, I'll go for that one because it just shaves a few more ounces off. And then this one is a good mix of the two. It doesn't have full protection, but it protects the lens and it holds a neutral density filter in case things are really bright. That's a good way to sort of manage, get a little bit more performance out of your GoPros. So battery tech. Now this was the skill that I really didn't expect was going to take as much learning power. Now quadcopters have to use lithium polymer batteries, and it's not not a light thing at all. Lithium polymer batteries, if they're not handled correctly and charged correctly, they will catch fire and like blow things up. So like I've had a couple of almost nuclear incidents with these things. But when you're doing a big gig, for example, this rig here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 batteries for a gig I had to do one Saturday. We were shooting rocket launches. And it was nuts, but that's like with the amount of batteries that you have to charge to keep things in the air, management becomes a real big issue. How to keep them between sessions to where they maintain life as long as possible. When do you charge them up? What do you do if you don't fly them and you come home? You need to have a good discharger so I could get them down to a storage voltage again quickly. And then along with this, I'm going to talk about some other types of craft that I built after the quads. Lithium ion batteries, which are used in most cases and are very safe. The reason that they don't work well for quadcopters is because they don't have a very fast discharge rate. They can hold a ton of power and they can give you a ton of power. They just can't do it very fast. So for a wing, something where there's a single engine, this isn't really a problem. But for quads where you're really managing 4 different engines in real time, you just have to have fast power delivery. So anytime we've tried to use lithium ions, they just die in like a minute and a half, and it's just not even worth the effort. So a lot of care needs to go into getting a good charger that can balance charge all of your batteries. Getting a good parallel charging board. That's what this board here in the middle is a way for me to basically plug 6 to 10 batteries in at once and treat them as one big super battery and charge them safely. That becomes really important when you're doing work at scale with drones like this too, just to make sure that you're not catching fire and exploding. But this was an area that I had to spend months researching and trying different types of batteries and like different storage temperatures. What do I do during cold shoots? Like there was all kinds of stuff that I needed to think about. Generally now I carry my batteries around in a bag, this bag here, which actually has a little portable heater inside it. So when I'm out on a gig, I pretty much have them all set to a consistent temperature. So if it's cold outside, they never drop down to an unsafe level. But like that's, you almost need to treat it like you're handling nuclear material. So the flight software, how do you actually program all this stuff and pull it together? Beta flights, there's a few different ones. There's Flight 1, there's Beta Flight. I'm spacing on a few. There's Butterflight. There's a few different variants and forks of the code now, but most of it came from the Beta Flight core. So it's what I stick with. It's just a really quick open source configurator and project and firmware behind it that lets you flash and load a standard flight controller chip. With this, it gives you access to basically customize it to whatever type of aircraft you might need to fly with a standard flight controller chip. You can choose the number of engines you have, whether it's a copter or a wing, so it knows how to understand thrust dynamics. You can tune the PIDs to where the response curve is exactly the way you like it. And and all the other fun stuff, what goes in your heads up display while you're flying, all that. Um, it's pretty safe and simple these days. So I think if you're going to be a maker, it's a great time to jump in because the software's gotten to a point where it isn't really experimental anymore. It's very well tested and is being used for commercial work all the time. So let's just kind of do a recap. We've been trying to talk about flight, but really like what this has involved so far. My need to get into the air meant I had to learn soldering and wiring, battery tech and health, 3D printing, aerodynamics, on-air transfer protocols, software design, video formats. Oh, and then the flying part. like that is definitely a bit of a tall order for most people. So just know that if you jump in, the coolest thing about this is exactly that. I kind of went in for the lulls, so to speak, and I came out with like just a trove of new skills I didn't think I was going to have to learn. Almost every single one of these skills I had to acquire as I went just to keep going. So the flying and the crashing, after all that too, we used to joke, this is like the meme we see, it can get spendy. So that's another reason why I do recommend like learning how to build if you're going to get into it. It just helps mitigate the cost. These days, it's standard components that I work with, and I have pretty standardized build processes too. So I can keep it pretty cheap. One of my drones, like number one here, is probably without the HD camera, like a GoPro, probably build this for about 120 bucks. And that's why I have a bunch of them. It's easy to replace. Crashing them, the frames you can usually get for these are single piece frames. For some of my more acrobatic drones, I use ones with removable arms, so that if I snap an arm, I can really quickly field replace it without having to just rebuild it. Unfortunately, that's why I have to carry 3 of these drones to gigs, because if one's out, one's out. Fortunately though, since they're all built from the same platform, I can switch camera mounts between them really quickly. I can kind of retrofit them to take on whatever characteristics I needed for the flight, and have 2 more backups. So let's take a little bit of a look. We've talked a lot through this. Again, the deck, in case anyone watching this recording wants to take a peek, is tinyurl.com/SAC Interactive FPV. And from here, you can also get to my YouTube channel for more questionable videos and a list of all the airframes and components I use too. Just to show you those real quick, here's my YouTube channel and an idea of the type of fun that you can have. Which actually, I'm just going to do it right off my computer, if that's okay. Video. Here's an acro example. So this is.
Oh, wow.
So as you can see, it's not your normal style of flying. It's not your average camera drone. These needed to be fast, quick, super responsive. On the other hand, you can do all that other stuff too. Betaflight gives you really great stabilization, auto flight characteristics. If you use iNav, which is a variant of it that's made more for wings, you can actually lock in GPS and do things like return to home also. So that same drone that just did this did really cool, slow, like wobble in shots like this over the ocean. This is for a short film. All the stuff you would expect. It can cover those too. Now, not to say I don't use Mavics and Skydios. They have their benefits and uses. In particular, when I want to go really high, I tend to use the camera drones more. And yep. This is me sending it back. So this is just using auto waypoints and stuff with iNav. Again, this is a custom drone, not a Mavic. So it's kind of fun to be able to really quickly with these open source components put together stuff like that. So a few of the things, as I mentioned, if you're building, you need a really good soldering iron. You really need like a little bit like some helping hands to work with the electronics. Makes it a little bit easier. A really good set of hex wrenches. and that's about it. A couple of GoPros. You're set and ready to roll. Now, the different types of quads that I've built, they have slightly different uses. And again, to be clear, most of what I'm doing is with trying to capture footage for people. For cinematic stuff, so a good example of that would be the really famous bowling alley fly through that everyone's seen a while. That's used with a type of thing called a Cinewhoop. These are kind of like a hybrid between the little teeny one I was showing you earlier and the big full-blown ones. They're made to have just enough power to lift a camera, but they're also usually tend to have these nice little guardrails around the propellers because they're used indoors. They're used in proximity around other things. So these are two that I've used. In fact, I've got these two right here. Let's just kind of hop out real quick, kind of take a peek at Cinewhoops in context. So this is called a squirt. I like this one because it's the vortex generators here are really nice. It doesn't have a ton of lift, but it can just hold this thing in place like nobody's business. The other thing that's really cool about it is you can bounce it off things. So it's hard to kind of show it from this side of the camera, but for really creative effects where you're doing things like that, you can actually kind of bounce it off walls and make it feel like a first person sort of drunk walking down a hallway that then kind of floats off into space. Like it's just some bizarre stuff. This is the Cinerat, the other one that I was just showing. They're roughly about the same size. It's just this one has a little bit more thrust and a little less protection. This one has a little less thrust and a little more protection. This one I use around people. This one I do not. I also have a super small Cinewhoop. This one, it's in my hand. This one, you can put this through the crack of a car window. You can do all kinds of bizarre shots, and it's not a 4K, but will capture 2K on that lens. So that's Cinewhoops. See, what are the next ones on my list here? Oh yeah. So we already took a look at the marmots. The marmots, these here, number one, these are the acrobatic drones, and they're made for that extreme footage. The types of jobs I've used these on are chasing cars at races. I've actually followed rockets at a rocket launch up off the pad. Lots of chasing people on bikes and skateboards. That happens like constantly. I think the most fun one I did was in a martial arts studio where we had done Cinewhoop footage on the inside, kind of going around the artists as they were spanning. And then I had one where we sort of faked it, where I shot everything up to a certain point with the Cinewhoop. Then I flew out the same pattern with number one here, but then did like 3 flips out and like flew off into the moon, and like that you could not do with the Cinewhoop. So that's some ways where I sometimes use the different flight characteristics just to kind of glue it all together. Cool thing is they both use the same camera. I literally do the Cinewhoop footage, pull the camera out, stick it in the marmot, put that one in the air, and get the acrobatic footage, and it all comes together beautifully because it's the same camera. And that's something you can't do with camera drones these days, unless you're putting a RED or a DSLR on something. So the micros, I don't do micros so much anymore. My son is really the micro wizard around here. My son has actually been on Rotor Riot flying my micros. So this was one of my micros I showed you earlier. This is the smaller one. These are really for fun. Honestly, what we do is we set up gates all through the house and then like race each other through the house with these. I mean, you've seen drone races. Just imagine on a really, really small scale where you can run into people and it's not going to hurt. I mean, we literally like dive bomb each other sometimes just to have fun. It's that safe and easy to use. From here, there's 2 that I do have to hop back over to screen share really quickly to show you a last. All right, here we go. So the racers I don't have here right now because they're actually all packed up to go to the field 2 days from now. This is my main racer. Now these ones are made to go just ridiculously fast. The props are highly angled. They have just an extreme angle of attack, so they are just grabbing air and throwing it as fast as they can. The engines are really heavily overpowered, And then I've also overpowered the battery side of it too. So this will only fly for about 4.5 minutes, which is about all you need for a race. But by the time that race is over, you have to turn it off, or if there's like fire risks, it gets hot. That's also part of the reason why the tech on this is stacked. That way air can kind of flow through all of it and really help keep it clear. I mentioned LEDs. These sort of panels on the arms here are not ESCs. These are LEDs. These can be programmed to whatever color I'm assigned at a race. They can also do things like flash red if I need to go into the pit to let my crew know that I'm dropping in and I need to do a swap. Yeah, all my racers are with red hardware too, just so I kind of know where they are. This is my backup racer. This is my main one, but this is an alternate that I have. This one actually is better for longer, flatter races, simply because it's got a different profile and it can kind of squeak around people easier. The one I was showing you earlier, this one's made to be more of a true X as opposed to a squashed X. That means it turns like an absolute beast. This thing will go straight from like 110 miles an hour down to a full 180-degree turn and then back up to that in 2 seconds. Like it's, again, you don't have to deal with the physics of it. You're not sitting in it, but I can assure you that even under goggles, when you hit the accelerator on this thing, most people puke. It's vomit inducing. It's so fast. But I love this one to death. It is so much fun. Now, of course, problem with these is you do drop them all the time. This is me fishing one out of the water after it went in. I was chasing dolphin pods out off that, and I got hit by a seagull, and he took me out, and I almost made it back to land, but I had to swim out to about 30 feet and grab it before it went all the way down, and I lost the LEDs. If the lights would have gone off, I would have lost it entirely. But yep, that's the downside of flying, as opposed to kind of RC cars and stuff that usually you bounce into things, they deal with it really well. These things, when you hit stuff or you go down, it's pretty epic, and it usually is not small. Again, another reason why it's great to be able to build. Now, the ones I want to show you now are what I got into later. And I'll be honest, quadcopters are great. You can do almost anything with them. But there was part of me that really likes to fly regular planes, like wings, just real like flight characteristics. I came from a skydiving background. I'm used to flying Cessnas and stuff. So I can show you the fun ones. Let's go from small to big. But I decided to start with my first wing. It's called the Nano Goblin. This uses exactly the same flight controller here that I've got right here. It's, again, consistent with all the other stuff. As opposed to that, the only difference between a wing and a quad is it really only has one ESC, which is kind of up in here, and one engine. So it's much easier. Throttle doesn't have to balance engines. You're not managing thrust. It's a lot of fun. This is also an FPV. It's an FPV drone. I don't like flying line of sight. So this one's very short distance. I can do this in like a football field range. Not much further than that. It's got a little teeny built-in antenna and VTX here for the video transfer. So after about 2 weeks of playing with this, I knew I needed more power. So the next one I built was considerably bigger. This is the Kaitarina. So this is a full-blown wing. It's in front. This is the HD camera here. There's a GoPro Session 5, one of the few last remaining in the world, because FPV pilots have smashed most of them by now. And then the FPV camera sits on the other wing over here. Inside, it's a pretty packed bay, but again, the same general setup. Flight controller. Oh, actually, the flight controller's over here on this one, and then videos in this bay. ESC is this big old thing sitting right here, and this battery is a beast. It's a monster one, but this one will fly for up to 2 hours. It's not like a little 5-minute freestyle, like extreme sports run. Caipirinha means business. The longest that a caipirinha has been flown was, I believe, all the way around Victoria Harbor and out to the islands and back in China. I know the farthest I've taken mine was out to the oil rigs off the coast of Santa Barbara, which is about a mile and a half, and then back again. But it's something. It's one thing to like do the little toys that end up running out of batteries in 5-10 minutes. It's another thing entirely to spend a whole hour and a half in the air, um, which is pretty amazing. I got really heavily into wings. They actually were very good for doing geological survey work. When I was down in Santa Barbara, there was a bunch of mudslides. The fires happened first, and then mudslides came after it. Probably heard about it. A bunch of people lost their lives in it. And for a while, there was a huge rebuilding effort. But in order to do that, they needed people to monitor the condition every morning before they sent the crews up. And I met a guy over coffee who said, "Yeah, we need to hire someone to do this." I'm like, hey, I think I could do that. And so I did that for a while. The wings really helped out because a lot of times we really didn't need like top down. It just needed to be visual. So I could fly really close near the tree line. Wasn't necessarily going way up and getting this top down shot, but it also would collect the GPS data as I went so they could tie it directly to the maps. And, they'd send a crew out. They could take a look at what it looked like an hour earlier. But this got me to a point where I realized I needed to start working on a new platform for wings that actually let me do all the stuff that I like to do. And that's when I made this one. So this is the Dart XL Extreme. It's got the whole 9 yards. Oversized ESC, same flight controller, same VTX. But this one has long range transfer in it. So this one will go just as far as the Caipirinha, but with an improved GPS module up on top and a completely separate bay down here to hold all the extra avionics and controls and stuff. I can basically put a scientific suite up here, a telemetry suite, whatever, and fly this thing for 2 hours. And I should probably mention that there are like laws for how high you're supposed to fly with this stuff. All I'm going to say is that these are rated for much, much more than that. So like they go well beyond your 200-foot altitude and, your roughly football field sized ranges. But there it is. That's kind of what I've been working on and why I've gotten into drones and stuff. So I hope y'all found that kind of interesting.
That was fantastic, Scott. I knew nothing about you or your background of this. Rob was the one who said, "Hey, let's talk to Scott and have him book a talk." I was like, "All right, that sounds cool." And I'm very worried that I now have a very expensive hobby under my that I'm gonna have to budget for and figure out like, okay, I gotta figure out how to get into this. This looks like it would be an absolute blast to start.
Totally.
Start that into.
It can be a tough one, but send me messages. I'll get you pointed in the right direction.
Oh yeah, I'll be definitely pinging you about things. If nothing else, we need to chat more about bands and stuff too, and I'll nerd out with you about drummers and things.
Awesome.
Can I ask you a few stupid questions? Some that I don't know the answer to, and some that I'm going to assume people watching the video might also not know the answer to. You mentioned earlier that there's latency with the digital versus the latency differences between digital and analog. What kind of latency do you typically see with a digital setup? Like ballpark?
The thing is, it's variable. That's how they manage their distance and their fault tolerance. Is they just, instead of like breakup, they just start introducing latency. With analog systems, it's just a predictable failure, I think is a good way of putting it. With digital, it kind of goes from everything looks great to wait, and then it's gone. With analog, you'll start to see it fuzz out. You will see degradation start to happen, but it's much more gentle. I think that's the real problem. But again, if you're not doing really fast flying and lots of quick maneuvers, even a variable latency may not be that bad. It just kind of reached a point where I needed my latency to be more like in the 15 to 18 milliseconds range at least. And when the digital would get kind of out there, man, it'd be like 30, 40, 50, kind of do it. And it just, I can't handle that. I need a consistent latency. I mean, I do fly the digital stuff, but it's under specific circumstances. If it's within a particular range. I usually do a couple of test flights for it just to make sure there aren't any of those really weird, like full dropout sections.
Hmm.
Um, it's just a little more controlled. On the flip side, digital gives you a beautiful picture when it's in, like it's like three times the quality of analog. Analog just gives you that immediacy that there's no other way to describe it. Like people usually look at it and say, why would you put up with like this kind of pixely looking screen? It's like because it feels right.
Right.
It's not that it looks like it looks good enough for me to like feel what it should feel like.
Hmm.
And that is like when I yank this, I almost want to kinetically feel it pull me to the side, like if I was yanking the stick in a real plane. So that's to me. I think that's to me that the sweet spot is really around like 10 to 12 milliseconds. You can get it down there, and with Crossfire as the protocol, the different control protocols actually play into that too, because you're dealing with a number of latencies that stack upon each other. So video latency is one thing, but if you've got like a 20-second video latency and like a 7 to 9 second lag here, it can just start to feel a little janky through goggles. like everything's doing what it's supposed to, but it feels like it kind of has its own mind about it. Like it doesn't always do it right away, but sometimes it does. And yeah, for me, especially the acrobatic stuff, like yeah, no bueno. I need like immediate response, and it
Sure.
has to be consistent. Um, Hopefully, I answered that.
Yeah, that did. Absolutely. Thank you. Um, you had a slide in your deck where you showed some of the different custom GoPro cases that you had, like the skull shaped one and one
Yeah,
for like better protection around the lens. And that I assume there are templates people can download for 3D printing of those
yeah,
online. You don't have to build those from
yeah,
scratch every time or
totally.
anything crazy. There's
I mean,
like,
yes and no.
um,
I've ended up taking a few of the STLs and then kind of like sort of reconverted and tweaked them in Fusion 3D to like get certain things. There's a couple I've made for scratch. Those really lightweight ones there, those ones I made from scratch just because I needed something super light and I really wanted to kind of really dial down the thickness on it too, just to squeeze as much like weight savings as I could out of it. But no, like for the most part, you can go to like Thingiverse and just download straight up files right now for most of the
okay.
cameras you need, and even the off brands. Like,
Oh, cool. Good. Thank you.
yeah, the thing to keep in mind is you want to stick with
Mhm.
a more common frame if you do that though. There's a couple of more generic frames, but really it's like making sure it mounts securely to your frame is
Sure.
even more important than like the camera fit because these days pretty much any camera would be supported on Thingiverse.
Yeah. Okay. Cool. Kind of related to that, you were also talking about batteries and storing the batteries at
Yep.
safe voltages and that sort of thing. I'm going to ask a stupid question. Why can't you just store the batteries when they have the maximum charge in them? Why do you have to discharge them completely before you, like, it's a battery and what they will organically just lose charge over time, like any battery
They
would.
do lose charge. These, well, particularly with lithium polymers. Let me pull one out so you can kind of take a look at the construction. These are 6 cell batteries, but they've got 6 individual cells.
Hmm.
It's not necessary. It's the fact that the cells will start to discharge at different values over time, and if they're not consistent when you hit it with a stick, it could flame up.
Got it.
Um, it'll pull too hard from one and create a temperature imbalance, and then you do that a few times,
Oh,
um,
gotcha.
flies. So it's all about the balancing is the real key. And a lot of consumer batteries that come like within a multi-cell configuration, that's part of the reason why they'll have like, hey, if you're not gonna use it, like, like charge it to like use it to 80% or something. And that's usually kind of a storage voltage is around 80%.
Hmm.
But that's just enough to take enough off the top to where it doesn't get into this weird imbalance that starts to discharge. It's usually more of an issue when you use it afterwards.
Gotcha.
Or when you go to charge it after that. If one cell is really out of balance and you go to hit it with a charger, yeah, that's when things really take off.
Gotcha.
This turns into a C4 in just a
Yikes.
couple of seconds.
We don't want that to happen.
No, it's not pretty.
Yeah, really.
It's like, and they won't go out. You have to find something to put it in and
Oh,
wait an hour
really?
or two. Yeah, they
Yikes.
just they'll burn and shoot
Wow.
flames. It's a sight to behold. Yeah, while we're talking here, let me see if I can find Lipo Fire on this. Why not? Yeah,
Sure.
there's got to be. Oh yeah, here we go. Let me pull this up and pause it. Share screen. I'm sure you guys are really Now we're really getting off road into the fun stuff. So here we go. Let's see if we can find where it happens. I'm going to scan and find. Oh, here we go. So,
Yikes.
so yeah, there's the individual cells going off.
Wow.
Probably be another one here too. I don't know how many cells that is, but yeah, this is what happens when you overcharge them. Here's see how they puff first, and
Hmm.
then it's it's not a pretty thing.
That is major. Wow.
Yeah, there was for a while there. It was sort of this kind of cool thing in the community. It's like share your best out at Lipo Fire, and then it's like it's funny when you say that, but then when everyone's like, "Yeah, here's my kitchen with a hole in the side of it.
Right.
Yeah, here's the remains of my house. It went down." And I am
Oh
not
man.
even exaggerating. I know people that
Yeah.
have lost their houses.
Yikes.
Um, it's crazy. Um, anyway, yeah, that's the main reason why to do it, at least with lipos. Also for traveling, that's the other time where
Oh, sure.
if the cells are out of imbalance and you're traveling, if it's like on a plane or something, oh my god, you can actually take lipos on your flight, but they're supposed to be at storage voltage and in a fireproof bag. So most of us, like my bag with the heater,
Hmm.
has like a total fireproof lining inside it too. It's I mean it's not perfect, but at least keep it to where it won't burn everything around it right away, and you can
Right.
get it and toss it fast. Like put it and throw it out the airlock it. Like do whatever you got to do.
I'm picturing scenes from action movies now where they, frantically open the door and throw the bomb out the window, out the side of the plane.
Right? Yeah.
Right.
I had one go off, and the picture I was showing earlier of my mass charging. I had one start to puff on my kitchen counter like that,
Oh, geez.
and flipped out. Basically, just I had kitchen tongs. I sort of grabbed the whole board and just threw it out the window into the driveway, and it exploded there. But
Yikes.
yeah, that's when I stopped charging inside entirely.
That sounds smart.
Well, I also got better at battery storage. That's when I really figured
Mhm.
my stuff out. I just have a battery monitor that you plug it in, and it will tell you immediately what each of the cells are charged to. So if one is really off, you can do what's called a balance run, which doesn't add voltage to it, but it basically it's I don't know, kind of like sifting the battery to where it all kind of shakes and evens itself back out again. You just connect all the different cells to one another like you're going to charge it, and then let it sit for a little bit, and it ends up balancing itself after a day or two. But that's like how you can sometimes fix it. Usually, if one starts to get in a big imbalance, the battery memory does something weird at that point, and you just have to just toss the battery.
That's better.
So
Got it.
it's a really big deal. You don't want to undercharge, like pull too much out of it while you're flying.
Hmm.
That's another reason why I'll have like one of the things I keep in my heads up display is my current voltage, and then I have an alert set if I get within 20% of a like a where it would technically puff. I was just going land now. I'm like shit. Let me bring it in. I also monitor temperature for the same reason. Between those two things is a good way of making sure you don't explode in the air. I
Hmm.
have seen people explode in the air. That's super fun. You can let it
Wow.
see the fire around you before it all dies. It's like fatality.
Wow. You mentioned learning circuit design as part of this. Are there any particular
Yeah,
resources that you liked for learning the circuit design part of this, and things you would recommend or not recommend?
that I'll be really honest. That was the part of it that was the most pulling my hair out, frustrating. There's a guy, Joshua Bardwell. The link is in the reference links in my deck.
Okay.
He has a channel. His called FPV Know It All, but he's like you literally can ask him anything, and he's got the answer. But he specifically helped me kind of translate, like, okay, well, what do you need to do? Got it. Like, here's what you need to know. For me, like most of the circuitry, like they're very small. So my biggest hurdle was getting really, really good at soldering. I don't know if you can see this, but like this is pre-tinned,
Yeah.
and that is some sweet little tin dots there. Like I got to the point where I now kind of take pride in my soldering, but like back then, a lot of my problems were actually manual. I'm like, why is this not working? Well, yeah, you've got like a couple of threads and some flux on that, and it's short circuiting. Duh. Like
Right.
But then I got a little bit better at it. The good news about the flight controllers in beta flight is that they're all built with largely standard options. So it really comes down to how you program the software to map to the board. And that tends to be the hardest part of it. Especially when I was shifting to these. This is the Radix Li. It's a micro board, a little micro controller underneath it. This is specifically for a wing. It's super light, but there's just some standard interfaces you would get from it. It's like a common API that everyone adapted. So fortunately, you don't have to do heavy circuit design. Most of where I did my work was adding things like GPS and like different kind of air sensors for the type of mapping I was doing, where it would basically save into a log GPS data, and with that GPS data, current air quality indicators for that point and that time. And that's what I'd hand over, would be a comma delimited file. Like here's the flight data. They'd plug it into their system, and they would all map it out for the construction and the the various repair crews that were going up to fix stuff. They could just immediately call up, okay, at 9 a.m., like the air quality was this, there was this much of X in the air, temperature was X, and that's the kind of stuff they wanted. That was most of my hard stuff. For the controller itself, you really there's kind of power ports that you can share across everything, and then you can also kind of sit just directly off the battery. I learned for certain things that have good voltage regulator components that already have good voltage regulators themselves. A lot of times I'll just run them like literally right to the hot inputs of the battery just to get nice clean power before it hits the distributor and gets sent out. There's usually a power conditioner in these too that will condition and kind of give you two standard, like a 12 volt and a 5 volt feeds for powering different units. And most onboard stuff runs at one of those two voltages. So those are some common ports that you generally use. And then there's what they call UARTs, which are these sort of open channels that you can use for anything. It's like there's an in and an out, just like a communication port pair. And you can program those to a lot of different things. You can use them for GPS. The sensors plug in through those. Very commonly, camera controls are used to do that. You can hook up relays and stuff to do different physical things on the craft while you're in the air, like servos and stuff. A lot of people like to do at least with the wings, a common thing that people will do is kind of put the camera up sort of in a pod slightly above it on a servo, and then hit a switch to turn it around and get a rear view real quick while they're flying. So a lot of things. So it's mostly the programming with the UART ports is where things get really fun. But a combination of that plus power, and you can run a whole lot of things through this. The other area that I did a lot of hacking on was there's a standard in for the camera where you don't run the camera directly from the camera to the transmitter that comes to your goggles. It kind of comes into the board first, and then the video signal gets sort of composited with your heads-up display. So it's like the horizon line that you see in fighter planes and stuff. And yeah, basically it's fighter plane look with, like, for me, it's speed and altitude up here. I've got like runtime, flight time, remaining kilowatt hours, like stuff like that. So I know what like my consumption for the flight is, how much more juice I've got in the tank, basically. And then everything on the bottom is more like state mode. So I usually use I have three different flight modes wired up to all of mine. I usually only keep it in acro, which is like no assistance, like just like take a nap controller pretty much. Just manual stick input. I'm an old school flyer. But then there's two different modes that you switch into regularly that you have to kind of program in from the switches here. And that would be horizon mode, which it kind of looks at an angle you define, but it won't let you tip further than this angle in any direction, which is really pretty cool. It lets you not make crazy moves that crash you, in a nutshell. And if you hit that, it's going to pretty much just try and level you again. And in this mode also, if you let go of the stick, it will level you with the gyro again, just get you right to true level as best as it can. And then there's like basically full assist mode. Like, what do they call it now? Oh my gosh, I haven't used it in so long. It's like the baby mode. It's it is pretty much, it's not going to let you. So horizon mode, I should have said, if it'll try and keep you in a certain area, but if you jank it really hard, you can flip it and stuff. It's just when you let go, it's going to always try and go back to flat. And I think that's the really key between acro mode and the others, is the others always will attempt to level you when you stop giving stick input. And so the Beyond Horizon, which will let you do limited acrobatics, but it always wants to level itself. Then there's like the other one is just straight up like, you cannot go past this level. You will not go past this level. Nothing you do will let you go past that level. And it controls your speed. In a quadcopter, your speed is also partly determined by your forward pitch, like how much the propellers are pushing you forward versus kind of forward. So it's pretty important with that too. Like you can't tip beyond this much, you're not going to be able to go very fast. And that's cool. It's a really good mode to have, especially if I'm letting someone new fly my craft. I'll throw it in one of those. Just like, if you're not comfortable, yeah, like let's leave it there for now. And then, yeah, the other, what is that one? Crap, they're all over the place now. Yeah, then this one with the GPS. This one is the additional like flight mode that has a fourth where it's actually like full blown, like register my takeoff point. If you lose signal, come back to where I'm at 200 feet above me. Like, that's it. And circle there until the control link's restored. That's like the way that works. And that's all the wings basically have that. I've learned that with wings. Unlike quadcopters, when they kind of lose power, they'll just drop. Like a wing, you lose power on that, goodbye. Like, it just keeps going. They fly great without any engine. That's also one of the reasons they fly so long, is you can actually like drop the throttle on them and just coast and kind of just really just use the thermals in the air to fly, which is nice. Especially, there's been a few times the reason I use the wings was mostly to go way off the coast, try and find like the pods of dolphins and whales and stuff if I could, mostly just to have an excuse to do it. But there was several times too where I just wasn't paying attention to my battery, missed my point of no return thing, and got to a point where I had to just float it in and run out to the beach and like try and catch it before it went too deep. Like, it happened.
Nice. Have you played much with the open source software itself? I'm blanking on the name of it. Not iNav, but the other one.
Betaflight?
Betaflight, yes, thank you. Have you played with the hacking?
Yeah, I played with I've hacked both of them pretty heavily.
What was your experience like with Betaflight? Like, is it easy to get in there and hack and do it? It's
so easy. You're mostly just hacking config files for the most part with Betaflight, unless you really, really want to change some performances. I did need to do that. There were some things like the range of PIDs that they covered. Like, I just had a really overweighted wing, and I needed to just go in and kind of, I need a little bit more. Like, I know you don't want me to do it, but I pulled down and just made a fork and made my own build and did that. They ended up taking it back, and then it kind of went in there as an option now too.
Oh,
so
cool.
It's cool. iNav is basically Betaflight, but for like really mission critical stuff. Betaflight is what everyone uses. It's just super easy. It doesn't have all the features of iNav necessarily, but it's got the stuff that really counts. So 90% of what I do is with Betaflight, but the wings, they're all on iNav now. Once I put the GPS in, just being able to do things like waypoints and stuff, where I can set a couple of waypoints, and if I lose the wing, I know it's going to fly back to a certain point, regardless of where it took off. Like, that's just so nice to know. And so,
right.
The places I like to fly, I usually have a couple of like basically alternate landing spots where if I have to put it down somewhere, the plane knows it can choose one of those that are closer. Like, it'll do that too, where there's two like landing points and it only has enough battery each one of them. It's smart enough to say, oh, yep, we're headed over here. That's sort of the difference between the two. It's really that automated flight stuff is where iNav is where it comes in handy. But if you want to just go up and fly crazy acrobatics, Betaflight all the way, all day. Like, it's good. It's reached a point where now I don't know why anyone would use anything else. It's just like, you could use it for commercial planes. It's that solid. I mean, I've never had an issue with the software itself. It's always ended up being my fault on wiring and the mapping.
Nice. I foresee a very expensive purchase in my future, and
Yeah. My recommendation to
rather
anyone who
than
wants to get in is get a tiny whoop first and fly around your house a little bit just to
yeah,
understand flight. It's much easier to repair a tiny whoop than like a 5-inch quad.
sure.
These things are a nightmare. You'll spend like 2 weeks just trying to fix, like get it running again.
Oh man.
Whereas a tiny whoop, they're just cheap. They're disposable almost. Um, and they're really fun to play. But the cool thing is they use they use Betaflight. They use like you use a full blown transmitter, full
Mhm.
blown set of goggles. So you can kind of get. That's what I did when to get into it. Was just I really tried a few different goggles and controllers, and then bought the ones I knew I was going to stick with the longest. That was the advice I got. That's the part that is going to be the most personal to you anyway. It needs to feel right. It needs to sit right. You need to be really comfortable with that because you're going to be using it with everything. Um, so that's my advice. Like, get a whoop, something that you can play with without spending a whole lot on the craft itself. If you're going to spend anything, like get a good transmitter. You can usually get by with reasonably cheap goggles for a little while, but eventually you will want to get something that is at least the HD analog, if not full blown digital. It's just,
Yeah.
I would say that you can fly without it, but once you've seen like HD, like control footage, it's just, oh my God, I wish it worked
Right.
all the time. um, yeah, and then from there, you don't even have to jump right into the building part. I think my first 5-inch quad, which is that's this size, this is enough to be absolutely terrifying to fly. It looks small, but when you're going from a tiny whoop to this, it's sort of like a Volkswagen to like a full blown McLaren. It's you hit the throttle and you are gone, and
Yeah.
it turns on a dime. It's a big jump. So a good way to go is there's a lot of places that you can buy RTF builds. So they're pre-built, but to certain specs that will generally work with, like if you've got in this case, I have Free Sky and Crossfire protocols right now in this. You can you could get them built to either one of those protocols. Spectrum is another really popular protocol. Um, some of them they have what's called bind and fly, which is everything is built out except for the receiver, the like control link receiver, and that it's like whatever you're using, just get yours, solder this here, this here, this here, good to go. um, and that was where I went in. Was I knew I had at the time I had a Spectrum transmitter when I first started, and it turned out that not a lot of like the vendors built the Spectrum, and I was kind of bummed because it was more of a wing protocol than anything else. So I couldn't do the full like ready to flies. I had to do the bind and flies, and that at least it took care of most of the building, but I still had to do a little soldering before I could even use it. So I felt like I was doing something. But then after I did that and then had to repair it a couple times after crashing it, that's when I bought number one. And I've never looked back since. In fact, everything I've built in the last 3 years is built on this frame. It's the Armiton Engineering from Australia. They just do amazing frames. The cages too. The reason I like these is the cages are made out of straight up titanium.
Oh wow.
So like if I hit something with this, it could destroy the HD camera, but my FPV camera that I'm looking out at isn't going anywhere.
Mhm.
Like, and then there's been many times I've hit things and had to keep flying. So that's just kind of a nice thing for me. I like knowing that the parts that connect to me the most are the most protected. And like if I lose an engine, like it's cool. At least I can land it because I can see.
Yeah.
So,
Nice. Thank you so much, Scott. This was fantastic.
absolutely. I'm glad you enjoyed it.
I did, absolutely. Um, for anyone watching the video, we always meet right here, third Wednesday of the month on the Zoom channel that I've got running. We're going to get back to in-person meetings as soon as we possibly can, as soon as it's safe because of COVID and all of that fun stuff that's been driving everyone crazy for a while. Hoping to get back to in-person soon, and we'll probably continue doing the Zoom YouTube thing when we do that as well. Going to turn off the recording. And Scott, thank you so much again. This was fantastic. I really appreciate your time and all the work you did putting together the slides and showing us,
It's
50 different amazing drones that you've got there. And I
already
had
did
never
all the
given them a
work.
ton of thought before. I had seen a few of them like at Concert in the Park downtown that would come in from the top and film the
Yeah.
bands playing. And that's been probably the most exposure I've had to drones, really, is just kind of seeing people doing them near me as part of an event that I was attending. And um,
Yeah.
man, this is really fantastic hearing the whole submersive level of detail about what everything is that you can get into with them and all that sort of thing.
I'm glad to share. I
Yeah.
feel bad if I've like impacted your wallet for the next year or two, but
Right.
at least you're gonna have fun.
Yes, exactly. I'm sure it'll be money well spent. Thank you
Right.
again. I appreciate it so much.
Absolutely. Take
Have a good night,
care.
sir. Bye.
You too.